Welcome to the DIY Honda Garage channel. The DTC P0107 indicates a problem with the manifold absolute pressure map sensor circuit, specifically that the voltage is lower than expected. This issue is crucial because the map sensor plays an important role in the engine control module's ECM calculations of engine load, affecting air-fuel mixture and overall engine performance. The map sensor is located in the engine compartment, connected by a 3-pin harness to facilitate signal transmission to the powertrain control module, PCM. The significance of monitoring the map sensor is paramount for maintaining optimal engine operation, efficiency, and emissions control. Start by documenting any freeze data and onboard snapshots as a prerequisite to troubleshooting, ensuring a detailed understanding of previous faults. This structured approach will guide you through identifying the underlying issue behind the P0107 DTC. The map sensor is responsible for measuring the intake manifold's absolute pressure, providing critical data to the PCM for air-fuel mixture calculations. It is located in the engine compartment, where it is connected by a 3-wire harness to the PCM. The sensor's role includes enabling the engine to adjust its performance by optimizing fuel injection and ignition timing based on the manifold pressure. In situations where the voltage from the map sensor circuit drops below 0.23 volts, the condition will trigger a DTC P0107. This low voltage indicates either a malfunction in the map sensor itself or an issue in the wiring and connections leading back to the PCM. Understanding the exact location and role of the map sensor facilitates more effective troubleshooting in the event of a fault like this. Several key factors can lead to the appearance of DTC P0107. A common cause is a faulty map sensor, which may not accurately measure the manifold pressure due to internal failure. Wiring issues can also contribute to this DTC, such as frayed, broken, or shorted wires impacting the signal. Poor connections between the map sensor and the PCM can further exacerbate this situation, leading to intermittent readings that eventually trigger the fault code. Each of these potential causes emphasizes the importance of systematic troubleshooting to isolate the problem accurately. Additionally, while the map sensor and its connections are the primary focus, always ensure to check for any related components that may influence sensor operation. The symptoms associated with DTC P0107 can significantly impact vehicle performance. A common indication is a noticeable loss of power, since the engine will not receive the correct air-fuel mixture for efficient combustion, leading to underperformance. Drivers may also experience engine stalling, particularly under load or rapid acceleration, resulting from incorrect readings sent to the PCM. Furthermore, when the map sensor malfunctions, it often leads to an increase in fuel consumption. Since the system might misinterpret atmospheric conditions, it can cause excessive fuel delivery, harming overall efficiency. Therefore, recognizing these symptoms allows for immediate investigation into the DTC, ultimately assisting in preventing further damage to the vehicle. In the first step of troubleshooting, begin by turning the ignition switch to the on position, ensuring all electrical systems are powered. Next, utilize the Honda Diagnostic System, HDS, to check the parameters and data related to the map sensor. Focus specifically on the voltage output of the map sensor. It should not fall below 0.23 volts under normal operating conditions. If the reading does match this threshold, you have successfully duplicated the failure, and you should proceed to the next diagnostic step. On the other hand, if the voltage is within acceptable levels, this indicates an intermittent issue, necessitating checks for loose terminals or poor connections within the map sensor's wiring harness and the PCM. Addressing these initial checks lays a strong foundation for further diagnosis. For the second troubleshooting step, turn the ignition switch to the lock position to ensure safety before handling the electrical components. Disconnect the map sensor by removing the 3P connector. This will allow you to isolate the sensor for further testing. After disconnection, turn the ignition switch back to the on position to power the vehicle's electronic systems once again. With the HDS still in use, recheck the map sensor readings for the voltage output. If the output remains below the 0.23 volts threshold, you can logically conclude that you should proceed to step 5 for further diagnostics. If not, it indicates a possible failure in the sensor itself. And the next troubleshooting step focuses on this area. During step 3, your focus shifts to measuring voltage between test points 1 and 2 on the map sensor's connector. Test point 1 is located at the map sensor 3P connector number 1, designated by a gray wire, while test point 2 is identified as the map sensor 3P connector number 3, which has a pink wire. Using a multimeter in this test will allow you to ascertain whether there is approximately 5.0 volts present. Finding this voltage is crucial, as its absence indicates that the map sensor may be faulty, prompting immediate replacement. Should you confirm the presence of a 5.0 volt reading, the issue likely doesn't originate from the map sensor itself, and you will move on to checking the wiring and connections involved. In step 4, turn the ignition switch back to the lock position, ensuring all components are powered down. Using the HDS, jump the SCS line to prepare for continuity testing. Disconnect the PCM connector C, consisting of 49 pins, while you check for continuity between test points labeled 1 and 2. These points are located at the PCM connector C, pin 23 with pink wire, and the MAP sensor 3P connector, also with a pink wire. Confirming continuity indicates that the VCC1 line is functioning correctly. If continuity is not present, this reveals an open in the wiring, requiring repairs to restore proper connection between the PCM and the map sensor. Ensuring this line is intact is critical for the map sensor's functionality and, consequently, the engine's performance. During the final troubleshooting step specific to DTC P0107, begin again by turning the ignition switch to the lock position. Then prepare for continuity checks. Jump the SCS line with the HDS and disconnect both the map sensor 3P connector and the PCM connector B, 49P. Your task now is to check for continuity between test points 1 and 2, the map sensor 3P connector number 2 with a green wire and body ground. This step is essential for identifying any shorts present in the map wire. If continuity is confirmed, this indicates that the wire is in good condition. Hence, you should focus on updating the PCM software if it is not current. Conversely, if there is no continuity, this reveals a short in the map wire requiring immediate repair to maintain connectivity and restore the system's operability. After completing all the necessary repairs and replacements related to DTC P0107, it's imperative to carry out a detailed repair verification procedure. Start by reconnecting all connectors that were previously disconnected during the troubleshooting steps, ensuring each connection is secure and intact. Once everything is connected, turn the ignition switch to the on position, allowing the PCM to power up. This is where you will reset the PCM using the HDS to clear any fault codes. After resetting, initiate the PCM idle learn procedure to help the system recalibrate. Finally, conduct one last check for any confirmed or pending DTCs using the HDS to ensure the repair was effective, ensuring that DTC P0107 or any other issues no longer arise. This final verification is not only crucial for confirming repairs, but also for achieving optimal vehicle performance. Engaging in preventive maintenance can mitigate the emergence of DTC P0107 and ensure the longevity of the MAP sensor and associated wiring. Regular inspections of the wiring and connectors can help you catch any potential fraying or corrosion before they lead to critical failures. Cleaning and securing sensor connections will also prevent intermittent faults that may not be immediately apparent. Additionally, keeping the PCM software updated is essential, as manufacturers often release updates to correct known issues, improve performance, or enhance diagnostic capabilities. This proactive approach will contribute significantly to maintaining optimal engine performance and frustrating fault codes from previewing in the future. Regular maintenance ultimately leads to a reliable and efficient vehicle. In conclusion, understanding the significance of the MAP sensor in engine performance, along with its associated troubles, is crucial for any Honda CRV owner. The DTC P0107 signifies low voltage in the MAP sensor circuit, which can result from various factors such as a faulty sensor, poor connections, or wiring issues. Systematic troubleshooting ensures that each component is examined and addressed specifically, making the process efficient and reliable. Moreover, incorporating preventive maintenance techniques helps to maintain sensor integrity and avoid future issues, providing peace of mind in vehicle operation. Remembering these key points will lead to a smoother performance and prolong the life of your Honda CRV. Please like and subscribe to the channel. See you next time.